Hiya, in this video I'm going to talk to you all about the different properties that you need to be able to recognise and understand from a quadratic graph. Things that will ask you for in an exam that you either have to do using a bit of mathematics, but today we're going to do it just from reading off from the picture, just to get us super familiar with the terms. So previously we've talked about linear functions. Whenever we've done equation with a straight line, that's called a linear function. And a linear function takes the equation of the form y equals ax plus b. And you might recognise that as being y equals mx plus c normally. That shows you a straight line. There's no power or anything involved. The minute we put an x squared in, it becomes what's known as a quadratic. Okay? So all those times when we were doing the difference of two squares, when we were doing trinomials, we were getting you to work on your factorising skills for quadratics. And that's really important because you're going to use those factorising skills again at some point, not today though. So quadratic functions are functions that take the form, and they can either look like this one here, where the brackets have been multiplied out, or they can look like this one here, which actually looks like a bit like completing the square. So this is why we complete the square, to get it to look like that. Either form that these appear in, these are called a quadratic. And the shape a quadratic makes is called a parabola. That's a bit of a funny word, isn't it? A parabola. So that's a quadratic. And then just a wee thing I want to point out is sometimes questions will write y equals, sometimes questions will write f of x equals. They're interchangeable, they mean the exact same thing, and we will see both, alright? So this here is our most basic, simplest quadratic. This is our starting point, if you will. So the most basic quadratic is y equals x squared. And it is this U shape, that's your parabola shape, and it goes through the origin, which means it goes through 0, 0. Now, as we start to move this graph around and reposition it, the equation will change, and we'll look at that a bit more in other lessons. But just be aware the equation, this is the most basic one, all right? Now, this is worth copying down. It's a really good trick to remember. If the quadratic is y equals x squared, i.e. a positive value, then we have a smiley face. So we have this U shape. Okay, now that's also called a minimum turning point, because where you go down and start to turn is low down. So that's what's called a minimum turning point. If the quadratic has a minus in front of it, so for example y equals negative x squared, that means we've got a sad face, right? And if you think about life, if you're negative, you're a sad person. So it goes that a negative is a sad face. And that's the number one trick I've ever learned and taught about quadratics. Positive x squared, smiley. Negative x squared, sad. And a negative x squared is like an N shape almost without the line. So that's called a maximum turning point. So really useful to remember these. Okay, so what I'm going to talk to you about is all these different things here. These are all the different buzzwords in quadratics that you'll hear in questions. So the first one is the roots. Now the roots are these bits here that I'm dotting in yellow. They are the points where your curve cuts the x-axis. And you've already been doing these and working these out. We've just not called it that yet. If you've been factorising a trinomial, for example, and you put it into two brackets, if you've been shown how to then break up those two brackets and put them both equal to 0 and maybe get the answer x equals 2, x equals 3, then that's you been actually finding the roots. That could be possible roots for this one, x equals 2 and x equals 3. So that is the roots. It's finding where it cuts the x-axis. And the way we do that is through factorising. The second thing they ask you about is your turning point. So this is your turning point here. Now there's different ways to get your turning point, okay? You can get your turning point by writing it and completing the square form. You can also get it, if you knew that these two roots were maybe 2 and 4, your turning point's in the middle, so it would be 3 something. And we know in maths, if we know one part of the coordinates, subbing it in will always get us the other one, don't we? So there's 2 ways of getting the turning point, but we'll talk more about that after. And then the nature, if it asks you the nature, it just wants you to write down, is it a maximum or a minimum? So this one, because it's a smiley face and the turning point is low, this is a minimum turning point. And the next thing they ask you about, which doesn't get done too well in exams, is the axis of symmetry. So the axis of symmetry is this dotted red line going down here. It's a line of symmetry and it goes right through your turning point. Now, any kind of vertical line like that is along the x coordinate's always the same, isn't it? So those lines have an equation of x equals and then whatever number it goes through. So if I knew my turning point was 3 something, my line of symmetry would be x equals 3. Again, we'll talk more about that again, but that's what the line of symmetry is. It's x equals a number. And then the last thing they ask you about is the y-intercept. And you've heard y-intercept before. That is from straight line. It's where your curve cuts y-axis. So that is along 0. So your x-coordinate is 0. So anytime you're ever asked to find y-axis, you need to now remember it's putting x equal to 0. So these are the different things. So what we're going to do is I'm going to give you a couple of diagrams and we're just going to practice writing down the answers from the diagram without having to do any mathematics or any factorising. That will come in a subsequent lesson. So here we've got a graph drawn. What I want to know is what are the roots. Now remember what we said the roots were. The roots are where it cut the x-axis. So the roots in this case are x equals 2 and x equals 8. Okay, it's always x equals for the roots. You could just write 2 and 8, but it's nicer to write x equals 2, x equals 8. Part B, we have a something turning point. Now, is this a maximum or a minimum? It's turning low, so this is a minimum turning point. Now, I can't fight in minimum, so I'm just going to write a min, right? So it's a minimum turning point. Now, where does this turning point occur? Now, it's right in the middle of 2 and 8. That number's missing from my diagram, but we can work that out. In the middle of 2 and 8, that's a gap of 6. So 3 away from each one makes that a 5. So my turning point is along 5, and I've already given you the down number here. It's along 5, down 9. So that turning point is 5, negative 9. Is that okay? And the last one is the the axis of symmetry. Remember, that's my red dotted line. And if you look at it, it goes through the number 5 in the x-axis. So the line of symmetry is just x equals 5. You can't just write 5 though. If you just write 5, you're not going to get full marks. And the last thing, the y-intercept is clearly marked on there as 0, 16. So there's my first example. And there was a wee element of work in there. I stuck that in. Example 2, right, straight away we can see this one looks a bit different. Can you see that the turning point's going the other way now? This is a sad face one, and if you have a look here, there's a negative in front of the x squared. Negative is sad, so that's why the shape has changed. Right, so we want to know when the roots are in this one. So the roots are, remember, down here where it cuts the x-axis. So the roots are when x equals, and I just always put them in order from left to right, when x equals negative 7 and when x equals 3. Now this time, because my turning point's up high, this is called a maximum turning point. Again, I'm just going to write max because I can't fit it in. So this is a maximum turning point. And I know the first part of the turning point is at negative 2. Oh, but I don't know the highest bit because that 21 isn't the turning point. I've not put on the highest bit the turning point. Now remember what I said a minute ago? If you know part of a coordinate, you know a value. So you know that the x value is negative 2. So what I'm going to do is into my equation, I'm going to sub in the number negative 2. So I'm going to do 21 take away 4 times negative 2 take away negative 2 squared. So that's 21. Double negative makes plus 8. Negative 2 squared is positive 4, but there's a take away, so take away 4. So technically there I've got 21 plus 8 is 29, take away 4 is 25. And that's higher than the 21, so that works. So my turning point is at negative 2, 25, right? That's what that point is there. Now the axis of symmetry is my red dotted line. It goes through minus 2, so x equals minus 2. And watch that matches the first number in my turning point. And then the y-intercept is drawn on this time. The y-intercept is there. The y-intercept is as a coordinate is 0, 21. So again, I snuck in a wee bit of work in there, all right? And then question 3, my last one. We're back to a smiley face, a positive x squared. So it says, when are the roots? So the roots can clearly be seen here. as where it cuts x-axis, minus 4 and 6. So x equals minus 4, x equals 6. This has got a low turning point, so this is a minimum. And the turning point is, oh, it's something minus 25. What's that number in the middle? What's in the middle of minus 4 and 6? Now, the difference from minus 4 to 6 is a gap of 10, okay? So half that would be 5. So what's 5 away from minus 4 and 5 away from 6? It's 1. So your turning point is at 1, negative 25. Okay? The axis of symmetry is that red dotted line. Now we already worked out that bit in the middle there was the number 1. So your line of symmetry is x equals 1. And then the y-intercept is marked on at negative 24 here. So that is 0, negative 24. Now one last wee bit I've added in here is I've asked us to factorise the equation. So this was the equation we were given at the beginning. Now if you factorise this into 2 brackets, numbers that multiply to 24 are 6 and 4. To get negative 2, it's going to be positive 4, take away 6. Now, just have a wee look for me just now. There's a 4 and a 6. My signs are the other way round. And the reason is because if I put that equal to 0 and then solve each of these, that gives me x equals negative 4, x equals 6. That matches my roots. So that's why I just threw that in as a wee extra bit. So, what you could go try and do now is just do exactly what I've done with a couple more examples for yourself. State the roots of the function. Now there's no extra working in these ones. I've been really, really clear. In all of them you can read off the coordinates, y-intercepts and things like that. So just play about and check that you could do all these from the picture. And in a future video, I'll do it with just the equation, no picture, okay? And then I've got a couple more, 6 more there for you to try. See how you got on with them. Thanks very much.